Till then, till the time they are sharing, we can discuss that at the end of the class, okay? When 10 to 20 minutes are there, till then, we can have our discussion, okay?
Okay, ma'am.
See, now in the last class, we were doing the numericals. Any problem regarding that, Umar?
No, ma'am.
No. Actually, remind me of one thing. Have we discussed the physical and the chemical change here? I don't think so. We have
Yes, ma'am,
discussed,
we did.
yes? Actually, we have done it, fine. So, apart from that, I think then the chapter is finished here. The chapter is completed here. Do you have any problem regarding that, or should we move on to more questions?
Ma'am, we can move on. I don't have any problems. Exam is done.
Okay, exam is done, fine. Also, I wanted to know, should I start the third chapter as of now, or you have some doubts? So then we'll take up more questions. If you don't have any doubt, then we'll start with the third chapter.
Yes, ma'am, we can start the third chapter.
Okay, fine. Then start with the third chapter. Atoms and molecules. Okay, I've got your paper. If you want to discuss it, then we can discuss it in a minute. Just 1 second.
You wish, ma'am.
Okay. Acha, how did it go from your side? According to you, how was it?
Ma'am, it was pretty bad because 90% of the question came from third chapter.
Third chapter. Hmm. Third chapter part is their majority. Fine, no worries. We will learn all of it in detail. Okay, come to the third chapter. Acha, a disclaimer before starting the third chapter. The third and the fourth chapter in 9th class chemistry, they are the basics of each and every chemistry part that you'll be learning in the higher classes. Okay, they are the foundations of actual chemistry. So please pay attention to these chapters, understand them from your side, practice them from your side, and revise them from your side. Okay, they are very conceptual, but they are the basics. They are the foundations of chemistry. Fine. So we'll be starting it like that.
Ma'am.
Yes.
Okay, ma'am.
Okay. Fine. So see here, we'll be. I'm quickly going through the topics that we'll be discussing in this chapter. So one is the history, a very brief discussion. Okay. Then we have very important laws of chemical combination. Then we have again very important Dalton's atomic theory. Then we have everything about the atom, the shape and the size, the symbol. Then a very important topic conceptually, atomic mass.
Okay, ma'am.
Then we have molecules. Then we have this chemical formula. And then we have molecular mass, also called as formula unit mass. Formula unit mass. These are the topics which are there in the third chapter, and we'll be having a good discussion on these topics. Should we start, Bacha? Are you ready?
Sure, ma'am.
Sure. See, I'll quickly try to give you a context of this chapter. In the first and the second chapters, we have tried to understand the physical nature and the chemical nature of the manner in which the particles are existing, right? Now we want to know what is that particle exactly. First, we are going to try to find it out, and then we are going to study about that particle. Okay, and that particle we know is atom. So let's quickly start with the history here. The history. See, history, we have two perspectives. One is the Indian philosophy, the other is the Greek philosophy. Okay, so both the philosophies are saying the same thing, but just in different manner. See, according to the Indian philosophy, A part. What do we mean by philosophy? Basically, they are giving the ideas, okay? They are giving their thoughts in a logical manner, but still without any proof or, concrete proof as such. That is the philosophy. So they were giving their ideas. They could not show any proof, but they were giving their ideas with some logic. That is what you are saying here as philosophy. Okay. And side by
Okay,
side,
ma'am.
we will learn with the Greek philosophy. Yeah. Indian philosophy, the first part is we had Maharishi Kannad. Okay. Around 500 BC. That was the time in which he gave this idea or the philosophy. He said that everything around us is Padarth. He called matter as Padarth. He called matter as Padarth. Okay. And he said that if we keep on dividing Padarth, we keep on getting small particles, but until we reach a stage out of, which we cannot further divide. So that last stage is indivisible. Now, obviously, if that last stage is indivisible, can we say that that is the smallest part of the matter or the padartha, right? Because that
Yes,
is not
ma'am.
divisible further. And that is nothing. What he called it as was Parmanu. He called that as Parmanu. Okay. He called that as Parmanu. So we keep on dividing Padarth, we keep on getting smaller and smaller parts until we reach a stage that is the stage of Parmanu, after which we cannot really divide that. Clear? That was the idea given by Maharishi Kannad in around 500 BC. Then we have Pakudha Katyayama. Pakudha Katyayama. Okay. He elaborated the same philosophy that which was given by Maharishi Kannad, and he said that the Parmanu exist in some combination. Exist in some combination, and that gives us different forms of matter. Right? That gives us different forms of matter. So he said he agreed with whatever Maharishi Kannad said, and he said that those Parmanus are existing in some combination to give us different forms of matter. Is it okay? Clear? Any problem here?
No, ma'am.
Fine. Now let's come to the Greek philosophy. In the Greek philosophy, the same idea was said just using different words. Okay, the same idea was said using different words. The first was Democritus and Leucippus. Okay, they said that matter is everywhere around us. Okay, and if we keep on dividing matter, we will keep on getting smaller and smaller parts until we reach a stage which is not further divisible. And what did they call that stage as? They call that as atom. They call that as atom.
Atom.
Now again the same thing, if atom is the one which is not getting further divisible, that clearly should be the smallest part there, right? That clearly should be the smallest part. And basically atom is coming from the word atomos in the Greek language, which meant indivisible. Indivisible. Fine, any problem here?
No, ma'am.
Fine. See, now come on to the name. So these were the early philosophies. There was no experimental proof as such. There was no practical experiments done as such to really understand these theories. It was in the 18th century that the scientists started doing the practicals or the experiments to find out whether these philosophies are right or not. And if these philosophies are not right, exactly what is the thing? How is it that matter is existing? And in that, we have two laws of combination, very important laws of chemical. See, Pakuda Katayama said that these parmanus or the atoms are existing in some combination, right? So what
Yes,
is that pattern in which those atoms are existing? And that we are able to understand through the laws of chemical combination. Now see, clearly it is saying that anything which is combining, right? It is something regarding the combination. And we know what is really combining. Different parmanus, different atoms are combining together to give us different forms of matter. That is what we know now, right? And that was the same thing said by Pakuta Katayama. So these laws are regarding the combination of atoms in which they are existing. Is that clear? Is the context clear?
Yes, ma'am.
Now, what do we mean by a law? What do we mean by a law? A law here means that it is something, the pattern. Let's suppose there's some pattern, right? I call any pattern as the law, then that pattern will be followed each and everywhere in the universe. Whatever reaction is happening, okay, let's suppose I'm talking about any reaction, okay, particular reaction. That if I call that a law, that means that is happening in each and every reaction which is taking place right now. We mean that by law. Is it okay? So that is the pattern is then throughout the universe. That's it. Okay. And what are the different laws of combination? The first one, very important, law of conservation of mass. Law of conservation of mass. Again,
Ma'am.
what is this law saying? Basically, it is based on this idea. What is the idea behind this? That mass can neither be created
Not destroyed.
nor not destroyed. Good. So basically, what is the reason of saying this here? See, let's try to understand this. Let's suppose there are 10 atoms combining, okay? 10 atoms combining together. Now these atoms are of different elements. These atoms are of different elements, fine. These 10 atoms I should get back as it is in the product. Then only I will have equal mass, no? Why? Because the mass
Yes,
that I
ma'am.
was giving in the reaction was because of those 10 atoms that I have in the reaction. I should have the same number of atoms back in the product, then only I will have the same mass, right? Yes or no?
Yes, ma'am.
So that is basically what are they saying? The atoms are combining. Atoms are combining, yet the total number of the atoms will be same. The atoms are combining, that's fine. Yet the total number of the atoms will be same. So let's quickly take this example. Let's suppose we have one element with two atoms, okay? We have one blue element, a blue element with just one atom, okay? And then we have purple with three atoms, okay? Now let's suppose what do we get here as the product? We get this. See, the combination has changed. You can see the combination has changed, but yet the total number of the atoms are same. How many black do we have here? Two. How many black do we have here? Two, right? How many blue do we have here? One. How many blue do we have here? One. How many purple do we have here? Three. How many purple do we have here? Three. Okay, that is what we are meaning by the conservation of mass here. Whatever mass we are putting in, that is because of the atoms, right? Because they are really combining. So I should have the same number of the atoms in the product also. The combination will change because they are combining, obviously, but the number will remain same. Is it okay? And therefore, what we say is this. This is the main point for you. Total mass of the reactants should be equal to the total mass of the product. That's it. Let's suppose we have 5 reactants, we'll add their masses. Let's suppose we just have 2 products, we will add their masses. But the masses on both the sides, the left hand side and the right hand side, should come to be equal. Fine, Umar, any problem here?
No, ma'am.
No. Should we quickly go for one example based on this? And we have it in the
Yes, ma'am.
NCRT. We have it in the NCRT, bache. Huh. See the first question. Just 1 second. Yes, it should be visible now completely.
Yes, ma'am.
See, read this question, please, on your own. Hanji. Let's try to understand this question. You have read it? Have you read it?
Yes, ma'am.
See, in a reaction, so a reaction is taking place, that's fine. So in a reaction, we need to understand 5.3 grams of sodium carbonate. 5.3 grams of sodium carbonate, huh? Reacted with 6 grams of acetic acid. So clearly these are the two reactants because they are reacting within themselves and we have some specific mass for them, okay? The products were, see, let's come to the products. 2.2 grams of carbon dioxide plus 0.9 grams of water plus 8.2 grams of sodium acetate. You can see here, they have given it. Now show that these observations are in agreement with the law of conservation of mass. What does the law of conservation of mass say? The total mass is conserved, right? So therefore the total mass on the reactant side should be equal to the total mass on the product side. Yes, Umar?
Yes, ma'am.
Okay, calculate it, bache, calculate it. Is the total mass same on both the sides? The total mass same on both the sides?
No, ma'am.
Let's see this. On the reactant side, 5.3 plus 6. How much does it give you? 11.3 grams, right?
Yes, ma'am.
Let's see it on the product side. 2.2 plus 0.9. 3.1 plus 8.2. 3.1 plus 8.2. 11.3. Is it
Yes,
understood?
ma'am. Kinda.
So this kind of, still kind of. What's the problem now? Please share that.
Uh, ma'am, one sec.
Yes, bache.
Yes, ma'am. The calculation part.
Sorry, I'm not able to hear you.
Ma'am, the calculation part.
Okay, with the calculation part. Okay, see. So on the reactant side, acha, are you understanding that how do we get these marks on the reactant side and how do we get these marks on the product side? Huh?
Yes, ma'am.
Fine. And if you have any problem, they have given the equation. See, sodium carbonate plus acetic acid, sodium acetate, carbon dioxide plus water. So clearly, sodium carbonate and acetic acid are the reactants. What is the mass? 5.3 grams plus 6 grams, right? Fine.
Yes, ma'am.
So that gives us a total of 11.3 grams. Any problem till here?
No, ma'am.
No. Come to the product side. So we have three products: carbon dioxide, water, and sodium acetate. What is the mass of carbon dioxide given as? 2.2 grams. That is given. You don't have to do anything in that. The other product is water, that is 0.9 grams. So definitely we'll add the masses, huh? We'll add the masses. The third product is 8.2 grams, sodium acetate. We add all of them together. Add all of them together. What do we get here? Please try to add them on your by your own. Quickly add them. See if you want 2.2 grams, 0.9 grams plus 8.2. 2 plus 9, 11. 11 plus 2, 13. 3 here, 1 carry, 3 plus 8, 11.3.
Yes, ma'am.
Is it understood now?
Yes, ma'am.
It's still not kinda, I hope 100% yes.
Yes, ma'am.
And what was the law saying? The law was saying the total mass on the reactant side should be equal to the total mass on the product side. Therefore, this is in agreement with the law of conservation of mass. Yes. Fine. Had this been
Yes, ma'am.
11.4 or 11 grams or 10 grams, you know the difference, then that clearly shows it is not in agreement with the law of conservation of mass. Therefore, the reaction is wrong because every reaction has to be in agreement with this law. Okay? Every reaction has to be in agreement with the laws. Fine.
Yes, ma'am.
The different kind of questions that could be given here are these. See, let's suppose they give you the total mass. Let's suppose this type of question. Okay, we have A plus B plus C. Okay, and they have given the product as D plus E. Clear? Now they have given the mass of A, B, and C. They have given the mass of A, B, and C. Let's suppose 10 grams plus 20 grams plus 30 grams. Okay, and they have given the mass of D as 40 grams. Okay, they are asking you the mass of E. How will you calculate this? We will first take the total mass here on the reactant side, bache. How much do you get? 10 plus 20, 30. 30 plus 30, 60. That is the total mass on the reactant side. But the total mass on the reactant side should be equal to the total mass on the product side also. Yes or no, bache?
Yes, ma'am.
So through this we can get the value of x, 60 minus 40 as 20 grams. That's it. Understood or not?
Yes, ma'am. Understood.
Understood. Now, next important point regarding this is this. If you are having the reaction in an open container, you must have seen this. See, there are containers, the beakers or the flask in the labs, right? And most of the
Yes, ma'am.
times, sometimes you must have seen we have a cork here, huh? We have a brown colored cork here that behaves as a cap on the flask, right?
Yes, ma'am.
Okay. What is the purpose for that? Let's suppose I have A plus B plus C reacting together, okay? And I get one of the products is carbon dioxide, the other is water, let's suppose, okay? So water will be there in the liquid form, it will be present here, fine, well and good. But carbon dioxide is a gas. Carbon dioxide is a gas. If we have not covered this, the carbon dioxide will actually evolve, will move out, will escape out, yes?
Yes, ma'am.
And then we will not be able to calculate the total mass of carbon dioxide. And then we will get a wrong result because we are not taking in the account the total mass of the carbon dioxide. Therefore, the total mass for this will not be equal to the total mass of this. Why? Because we are not even taking the mass of this, right? Why are we not
Yes,
taking the mass? Because it has actually skipped out. But if we are doing it in a closed container, then the gas will be there as it is. So therefore, the total mass will come out to be equal as the total mass of the reactants. Fine.
yes, ma'am.
Coming on to the next law of this law was given by
Yes, ma'am.
Lavoisier in 1774. Okay, this law was given by Lavoisier in 1774. Coming on to the second law of chemical combination, law of constant proportion. Law of constant proportion. Are you writing or should I start explaining?
Ma'am, you can start explaining.
Okay, see. I would want you to recall the concepts from the second chapter that we were learning about the compounds. We saw in the second chapter that compounds are formed when a fixed proportion of the elements are combined together, right? When a fixed proportion of the elements are combined together. The scientists observed that each and every compound in the world has a fixed proportion. Right? What does that mean? See, for water, we have two hydrogen atoms bonded to one oxygen atom. Huh? This is the fixed ratio. If we have two oxygen atoms, then we cannot call this as water. See, is this water? Is this water?
No, ma'am.
No. If I call this, is this water?
No, ma'am.
No. So that means here, why are we not calling these as water? Because see, water has two atoms of hydrogen bonded to one atom of oxygen. In this case, we have two atoms of oxygen. Here we have two atoms of oxygen and one atom of water, hydrogen. So clearly both of these are not water, right? So water molecule or water compound is formed when two atoms of hydrogen bond to one atom of oxygen. That is their proportion. For carbon dioxide, see, for carbon dioxide, we have one atom of carbon bonded to two atoms of oxygen. If you make it like this, it becomes a different compound. It is carbon monoxide. It is no more carbon dioxide, right? Or if you make it like this, it is not carbon dioxide. It is some random compound. So what are we saying is that for carbon dioxide to be there, there will be one atom of carbon bonded to two atoms of
Oxygen.
oxygen. So don't you think there is some proportion in which the elements are bonding or combining to form the compounds, right? The elements are combining together in some proportion. That is what this law talks about. Okay, that proportion is something that this law talks about. Clear? So let's quickly come to the NCRT here. Lavoisier, along with other scientists, noted that many compounds are composed of two or more elements. That is very obvious. Compounds are formed when two or more than two elements are combined together. And each such compound had the same elements in the same proportion. Each such compound had the same element in the same proportion. Mean if you are talking about water, water will have water, hydrogen and oxygen in a fixed proportion. If you are talking about carbon dioxide will have carbon and oxygen in the same proportion, right? One atom of carbon bonded to two atoms of oxygen. Yes. So likewise,
Yes,
we
ma'am.
had each and every element had the same elements, and they were combining in a fixed ratio proportion. This was observed by Lavoisier. See, irrespective of where the compound came from or who prepared it. Let's suppose you take water from Saudi, we take water from India. Okay, what will happen? Will water composition change? Will you have three atoms of oxygen bonded to two atoms of hydrogen? No. You will also have two atoms of hydrogen bonded to one atom of oxygen, right? We will also have two atoms of hydrogen bonded to one atom of oxygen. So, what are we seeing? Whatever is the source, whatever is the source of preparation, we are still having the same proportion, no?
Yes, ma'am.
Yes. So, that was observed by him. Now, see, in a compound such as water, important, please pay attention. The ratio of the mass of hydrogen, see, come to this point here. We will just take the example of water and we'll try to understand this law. Yeah. H2O. This is one molecule of this compound. This is a compound, and how many molecules have? One molecule of this compound, okay? And two atoms of hydrogen plus how many atoms of oxygen? One atom of oxygen, okay? Don't you think, Umar, if there are two atoms always in every water molecule, the mass of these two atoms will also be same? Yes or no?
Yes, ma'am.
The mass of these two atoms will also be same. This is a very simple example. Try to understand this. Let's suppose I have a suitcase and I'm taking, every time I'm taking just two footballs, okay? I'm taking two footballs. So don't you think every time I should get the same mass? Irrespective of wherever I'm going, whoever is packing them, I should get the same mass. Yes or no? Why? Because in the
Yes, ma'am.
suitcase, I'm always having two footballs. That's the same thing. If every water molecule is having two atoms of hydrogen and one atom of oxygen, the mass due to these two atoms of hydrogen and one atom of oxygen should always be same. Yes or no? Should always be same.
Yes, ma'am.
And that is what we call as ratio by mass. Okay, of elements. In water, we have two elements, hydrogen and oxygen. And hydrogen has two atoms, oxygen has one atom. So therefore, the mass due to hydrogen will also be fixed, and the mass due to oxygen will also be fixed. Let's quickly see that. So there are two atoms of hydrogen, 2 into 1U. You don't have to go into detail as to how do we get 1U, but 1U is nothing but the mass of one hydrogen atom. Mass of, okay, plus how many atoms of oxygen?
2.
One. Are you sleeping? How many
I know,
atoms
ma'am.
of oxygen? One. Okay. What is
Okay,
this
ma'am.
16U? Mass of one oxygen atom. Clear? What is the proportion that we are getting? See, this forms 2U. Huh? 2 is to 2 is to 16, no? 2 is to 16. What is the mass due to oxygen? 1 is to 16. Therefore, we get 2 is to 16. What is the simplest ratio that we are getting? 1 is to 8? Yes or no?
Yes, ma'am.
Are you even understanding this, Umar?
I guess I'm understanding.
Okay, fine. So this is 1 is to 8. Now, what does this 1 is to 8 mean? That means every time we are taking one part of hydrogen in mass, I'm not talking about a volume, I'm not talking about the numbers of atom. I'm talking about one part of hydrogen by mass, then I will have 8 parts of oxygen by mass. Example, if I'm having 1 gram of hydrogen, I will have 8 grams of oxygen to combine with that 1 gram of hydrogen to give me water. To give me water. Is it understood? Therefore, if 9 grams of water is decomposed, we get 1 gram of hydrogen plus 8 grams of oxygen. Yes?
Yes, ma'am.
Always 1:8, whatever the source of water is. Wherever you are taking hydrogen from, wherever you are taking oxygen from, wherever you are taking water from, always hydrogen will combine with oxygen in the ratio of 1:8 to give you water. Always. That's it. Thus, if 9 grams of water is decomposed, 1 gram of hydrogen and 8 grams of oxygen are always obtained. Similarly, in ammonia, the nitrogen and hydrogen are always present in the ratio 14:3 by mass. This is again important, whatever the method is obtained. See, what is the formula for ammonia? NH3. What is the formula for ammonia?
NH3.
1 atom of nitrogen, 1 atom of nitrogen plus bonded to how many atoms of hydrogen?
2, 1.
3. Are you not able to see the number, bache? 3 atoms of
Yes, sir.
hydrogen. Okay, so the mass due to 1 atom of nitrogen and the mass due to 3 atoms of hydrogen will also be fixed. Yep. And the
Yes,
mass
ma'am.
of 1 atom of hydrogen is 14. Proportion 3 atoms of hydrogen means 3, because the mass of 1 atom is 1. I mean 1 atom of hydrogen is 1, right? So therefore 14
Yes,
is to
ma'am.
3 is the ratio for ammonia. If nitrogen is taken 14 times combining with 3 times of hydrogen by mass, what we will get? We will get ammonia. What we will get?
Ammonia.
Ammonia. Fine. That's it. Let's quickly come to the questions here. Okay. If I have 9 grams of hydrogen, okay, I have 9 grams of hydrogen. How much oxygen will it react with to form water? To form
Water.
water. Try to solve it very quickly.
Okay, ma'am.
Yes, Umar, done. Hello.
No, ma'am.
Achha. But I want to know one thing. Could you please wait for a second and please answer this thing to me?
Sure,
I'm going
ma'am.
through your I'm going through your question paper, and what I'm seeing is we have questions from the part of the chapter 2, which is methods of separation techniques, right?
Yes, ma'am.
And we don't have it in the syllabus now. So has that been taught in your school?
Yes, ma'am.
What book are they referring to for this?
Ma'am, they're using a guide.
They're using the guide. They are not sticking to the NCERT.
I know, ma'am. We left NCERT 2 years ago.
No, that's fine, but still, bache, the course book is still for the CBSE is the NCERT. I understand that you people are having the guides for the reference, but actually the point is the course book according to the board is still NCERT. Okay, so what we do is that we stick to the NCERT. We take some points from the reference book or the guide, but still we stick to the NCERT. So, but then if they're doing it, then we will do it, inshallah. But then that is not there in the board syllabus, right? I mean,
Yes,
by
ma'am.
board, I mean according to the main board, that is CBSE. So
Yes, ma'am.
then they also have the mole part here, mole concept here. That also we don't have in the syllabus. So let me just discuss this with the team and then I'll tell you. But obviously, inshallah, we will do it. Then we need more time for this.
Okay, ma'am.
Fine. So yes, see how do we do this question? Please see here. How do we do this? Just tell me what is the ratio? What do we need to form the water? Water is a compound. What two elements combine to form water? Hydrogen and.
Oxygen.
So, in what ratio do they combine hydrogen and oxygen? What
One
is
by
the
eight.
ratio?
1:8.
So, one part of hydrogen and 8 parts of oxygen. I can write it like this, right? I can write it like this. Now, see,
Yes, ma'am.
whatever mass of hydrogen I'm taking, or whatever mass of oxygen I'm taking, they should be in such a ratio that when I simplify them, they should give me 1:8. Yes. They should give me 1:8 because that is the ratio in which they are combining. That is the proportion in which they are combining. Are you getting this?
Yes,
So
ma'am.
I can write it like this. 9 grams of hydrogen have been given to me. I have to find the mass of oxygen. See, the point is this. If I simplify 9 by x, I should get what value? 1:8, right? I should get 1 upon 8. So see, this is simple maths here. We can crisscross it. We can cross multiply it. 9 into 8 gives me x. What is 9 into 8? What is 9 8 is 72? What is 9 8 is
Yes, ma'am.
72? 72 grams is x. What is x? Mass of oxygen with which 9 grams of hydrogen will bond or combine to form what? Water. To form water. Is that understood or not?
Yes, I understood.
Fine. I'll give you just one more question. Please try to answer me very quickly. I
Okay, ma'am.
have 28 grams of nitrogen. Okay. How much hydrogen will it combine with to form ammonia? Okay, NH3. That's it. The paper was quite lengthy and quite conceptual. It was not an easy paper. I mean, not
Yes,
a very direct paper. What about physics and biology? How did that go?
ma'am. It is really easy.
Mm. You'll have to take in more time because when your school is having all these topics in the syllabus, we'll have to give it more time. Fine. Have you done the question?
No, ma'am.
See, what is it that is need to be formed? Ammonia, right? So nitrogen and hydrogen. What is the ratio in which they combine? 14 is to
Nitrogen, hydrogen.
14 is to
14 is
3.
2.
3 bache. 3.
Yes, ma'am.
Okay. So how much nitrogen do we have? 28. We need to find out hydrogen. Can I represent it by X? You will just
Yes,
cross
ma'am.
multiply it. So 14x is equal to 3 into 28. X is equal to 3 into 28 divided by 14. 14 ones are 14 twos are. So is equal to 6 grams. Is it fine, Umar?
Yes, ma'am.
So 28 grams of nitrogen will combine with 6 grams of hydrogen to form what? To form ammonia, that is NH3.
Nitrogen. Yes, ma'am.
Ammonia, nitrogen, NH3, okay?
Okay,
This
ma'am.
is called as ammonia. The name of this compound is?
Ammonia.
Okay? I think that should
Okay,
be clear
ma'am.
now.
Yes, ma'am.
Okay. So inshallah in the next class, we'll continue with other topics. Let's quickly come to the discussion of the questions, okay? Just one second.
Okay, ma'am.
You have your paper by your side?
Yes, ma'am.
Okay. See. Question 1. What is the name of the metal which exists in liquid state at room temperature? That is mercury.
Mercury.
Fine, good. Which of the following non-metal is a good conductor of electricity? What is it? Graphite.
Graphite.
Good. How can one separate ammonium chloride from a mixture containing ammonium chloride and sodium chloride? Now, again, these topics we have not even discussed, okay? Acha, Omar, also when we were discussing the second chapter, you should have just let me know, ma'am, we are also having these topics. Huh?
Okay, ma'am.
Not okay. I mean, just from the next time, just let me know of anything because your school is going different from the book, which is the NCRT. So, ammonium chloride from a mixture containing ammonium chloride and sodium chloride, that will be through precipitation and sublimation. What is the chemical formula of sodium carbonate? Na2CO3.
Ma'am, NH3CO2.
Sodium carbonate is A part Na2CO3.
Yes, ma'am. That.
NaHCO3 sodium bicarbonate. Okay.
Okay, ma'am.
Na2CO3 is sodium carbonate and NaHCO3 is sodium bicarbonate. Okay, so don't get confused. What is the which of the following properties does not describe a compound?
Ma'am, it is a pure substance.
But it is a pure substance. The D
Yes,
part
ma'am.
is the D part, it is mixed in any proportion by mass because it is always in a fixed proportion. So D part does not describe the properties of a compound. Solid solution in which the solute is gas. Solution is solid. Okay, solute is gas. And the answer here is solution of hydrogen and palladium.
Yes, ma'am.
Solution of hydrogen in palladium. Fine. Next chemistry question we have. Question 17. When a beam of light is passed through a colloidal solution placed in a dark place, the path of the beam becomes visible. Light gets scattered by the colloidal particles. Yes, both of them are true. Huh?
Ma'am, A.
Yes. A, both of them are true, and R is the correct answer. Reason for A. That's right. Assertion.
Yes,
Good.
ma'am.
Come to the question 21. Which one did you attempt to make a saturated solution, or the second part, 0.24 sample of the compound? Which one did you attempt?
Ma'am, I skipped the question. 2 marks.
But why did you skip the questions? We have practiced the first part in the class. See,
Yes, ma'am.
we have practiced it. Why did you skip that? See, to make a saturated solution, 36 grams of sodium chloride is dissolved. So this is the solute. Is dissolved in 100 grams of water. This is nothing but solvent. Find its concentration at this temperature. How do we find the concentration? Mass of solute, okay, upon the mass of solution. How do we get the mass of the solution? We add the mass of the solute and the solvent. Umar, we have done this, bache.
Yes,
That's
ma'am.
the equation why did you not solve it then? Huh?
Ma'am, I forgot during exam.
Come to the next one. Mm, fine. Write down the formula of sodium oxide again, aluminum chloride, sodium sulfide again, the third chapter. Again, quickly tell you the answer. Sodium oxide is Na2O. Aluminum
Ma'am,
chloride
I
is
wrote anything. I wrote NaO.
It is Na2O. Second is aluminum chloride, AlCl3. The third is
Yes, ma'am.
sodium sulfide. Sodium sulfide is this. Fine.
Yes, ma'am.
The write down the names. So you have done the first part, right? Not the second thing. Write down the
Yes,
names
ma'am.
of
First part.
compounds. Okay. Now, how are salt solution and suspension different from each other? We have done this many times. I hope that is correct.
Yes, ma'am. I wrote a
Okay.
different part too.
And so you have done the different part. Just one second. Explain the
The odd
following by
one.
given example. Okay. Colloid. Bache, all three of them had to be explained. Saturated solution, what example did you give?
And ma'am, for saturated solution, I gave sugar water. No, ma'am, saturated solution, I forgot the example. But for pure substance, I wrote water for pure substance, and for colloid, I wrote soapy water.
Okay, for colloid you wrote?
Soapy water.
Okay, fine. Soapy water. Okay, fine. Makes sense. Now the next thing, convert into a mole. So 12 grams of oxygen gas, how many moles we will have? 12 divided by 16. Okay, so 0.75 moles. The first part. The second part is 20 grams of water. N is equal to 20 by 18. We can solve it to get the answer. Third is, Omar, were you able to do any of these, bache? Mole concept?
No, ma'am, I lost 5 marks there.
22 grams of carbon dioxide. 0.5 moles. Again, everything is from the third chapter now. Inshallah, we will discuss all of these then in the third chapter. There is no point of discussing these answers here because when you don't know the concept, okay? So we'll discuss all the concepts in detail, inshallah, and then we'll learn all these things. Is that okay with you, or should I let you know of all the answers that you have in your question paper? Whatever is your call.
Ma'am, from third chapter, I was able to do some questions because self study, but the mole one and some others I wasn't able to do.
I understand that. So tell me, should I tell you the answers of every question which is related to the third chapter, or should I wait when we are doing the third chapter? Then we should discuss that. Whatever is okay with you.
Ma'am, I think we should wait.
Okay, fine. So then, inshallah, we will discuss these problems also in detail. Okay.
Okay, ma'am.
Okay. But mm, mm, no, but can I just ask you one thing? Why is your school not following the syllabus?
Well, ma'am, because our school is about to follow the syllabus, but our science teacher recommended the principal that we should follow the guidance because it makes studying easier for students. So that's why we start following guide.
What guide are you using? What guide? What author? The name?
Ma'am, I have no idea.
I- Is it Arihant? Is it S. Chand? Is it Educard?
Yes,
What
ma'am,
is the book
stand.
being?
I think it's
S.
stand.
Acha, you people are following S. Chand. That is too much of details there. Not every detail is needed for your syllabus. Fine, I will look into that and we will discuss all these topics then, inshallah.